In this video, I introduce LoRA, low-rank adaption of large language models. Low-rank adaption freezes the pre-trained model weights and injects trainable rank decomposition matrices into each layer of the transformer architecture. This is a pre-trained model, and this is trainable rank decomposition matrices A and B, which can reduce the number of trainable parameters for downstream tasks. LoRA uses a shared single pre-trained model to build many small LoRA modules for different tasks, namely switch the tasks by replacing the matrices A and B, which significantly reduces the storage requirement and the task switching overhead. Given a pre-trained autoregressive language model B and a training dataset Z, LoRA uses the pre-trained model to generate a conditional task. The objective is to solve the following maximum problem as shown here. A regular fine-tuning requires learning delta V, whose dimension is the same as the model parameters of the pre-trained model. LoRA encodes delta V with the much smaller set of parameters set. Finding delta V becomes maximizing log likelihood of the next word over theta as shown here. For a pre-trained weight matrix W0, the update is represented with low rank decomposition as shown here, where the rank R is much smaller than minimum of D and K. Since W0 is frozen, LoRA updates the model parameters without computing gradient, and instead computing trainable parameters A and B. One hidden state H of a pre-trained language model is computed by here, where X is input from a previous layer. LoRA fine-tunes the model where B by A shown here and in this figure, where A is initialized with a random Gaussian distribution and B is initialized with 0. In a multi-head attention transformer, LoRA is applied to fine-tune 4 matrices WQ, WK, WV, and WO, as shown here and here, while fixing the feed-forward network parameters, as shown here in the pre-trained model. Each matrix W corresponds to a pair of B and A that will be learned by LoRA. Each downstream task has its own B and A and shares the pre-trained model parameters W0. LoRA has a better performance than other fine-tuning methods, as shown here. For more details, please check with these references. Thank you. Bye.